4.2 Triangle Congruence by SSS and SAS. If you remember from last lesson, we had to prove that our figures were congruent by showing that all corresponding sides were congruent and all corresponding angles were congruent. And after a couple of proofs of that, I'm sure you are saying there has got to be a better way. Well, there is. There are actually 5 better ways, and the first 2 are right here. We are going to prove that our triangles are congruent using our side, 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 and side, angle, side postulates. So we started out 4.1, and we said that triangles where all of the corresponding angles and all of the corresponding sides are congruent. And we wrote a congruence statement. We really don't need all of this. So we are going to simplify it here. And our first one is the side, side, side postulate. And you can shorten this to SSS postulate. And what this postulate says, if 3 sides of one triangle are congruent to 3 sides of another triangle, then your triangles are congruent. So this requires no angles. All we need are 3 congruent sides. Now, once again, this is a postulate, and so it is accepted as fact. And if you think about this, if you have 3 toothpicks that are a given length, so let's say 3, 4, and 5 units long, there is one and only one triangle that you can build using that. And that's why any 3 lengths are going to make the same triangle over and over. Let's look at a proof using this. We have a diagram here. We are given that segment LM and segment NP are congruent, and we are given that segment LP and segment NM are congruent. And we are looking for a way to make our triangles congruent. Well, we need a third side, and hopefully you are seeing it right here as our reflexive property of congruence. That gives us 3 sides. Now, how do we name this triangle? Well, once again, there are tricks that we can use. You can start anywhere. But last time I told you if you start with angle marker 1 and go to angle marker 2 and then go to angle marker 3, that it's really easy to name. This time we don't have any angle markers though. So you need to pick a point, and I usually like to go alongside 1 and then alongside 2, and then that would take us back alongside 3. So I would name this triangle, I would go N to P to L. And then when I looked at my other triangle, I would find side 1 to side 2, so I would know that I would go this direction. So that would be L to M to N. So it doesn't matter where you start, but making good decisions will be helpful. All right, why don't you pause the video and try to do the next proof on your own. Okay, this theorem, or this proof, is exactly the same proof that we just did. Now, I redrew my triangles and separated them out, and I was given 2 sides that were congruent. So I said, you know what? I bet that I can use the SSS postulate here. I need a third side. I could see here that these two triangles share this line. So that line is going to be congruent, that segment is going to be congruent to itself by the reflexive property of congruence. That gives me 3 sides. So my first 2 sides, this is side 1 and side 2 here, are given to me. Side 3 comes from the reflexive property of congruence. And then I can write a congruence statement, and B, C, D is the same as B, F, D, and that's what I was asked to do. And the triangles are congruent by the side, side, side postulate. So I really believe you can do these. Use your define, explore, redraw, label everything, and you'll get along just fine. All right. Our next theorem, we need a little bit of vocabulary here. We are going to be talking about corresponding sides and an included angle. Included, if you include something, you make sure that it's part of the group. An included angle, angle A here, is included, and it's included between 2 segments. Angle A is included between segment BA and segment AC. Now, something that we are going to use later on, you can also have an included segment. Segment BC is included between angle B and angle C. So angle B and angle C are on the outside. Segment BC is in between. Angle A is between, and our 2 segments are on the outside. So included is important to us here. Let's look and see why. Our side angle side postulate, guess which parts of the triangle we're going to be using for congruence here. I bet we have a side and an angle and another side. And look at where this angle is positioned. It is included between those 2 sides. So what this postulate says, if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then your triangles are congruent. Now, order again, you know, is important. So let's look at our 2 sides here. Right? We've got our 2 congruent sides. And then where is angle A? Angle A is between those congruent sides. It is included between those congruent sides. This is extremely important. So let's look at some problems here. We are asked, what other information do we need to prove that these 2 triangles are congruent by side angle side? Well, let's look at what we have. We have this side and this side, and we have this side here. So if I redraw my triangles, just real quick, they don't have to be perfect, but it lets us see what we have. We have a side here and a side here, and then we have a side here and a side here. So what do we need for side angle side? We need the included angle. And so it's angle EFD for the top triangle, and it's angle GDF for the bottom triangle. Now take a look at our congruence statement. E, F, and back to D, G, D, and back to F. Of course, those are the angles that we need. Right? Those are the same position in our congruence statement. Do those angles look like anything you recognize? Did you say, hey, if we had some parallel lines, those could possibly be alternate interior angles? If you said that, you're right. All right, so go ahead and pause and figure out the next problem. All right, you should have decided that we need segment EL to be congruent to segment NB, because what we started out with, we were given congruent angles, okay, and then we have a side that's congruent by reflexive property of congruence, and we want side angle side. So we have to choose the side that would make the angle an included angle, because included is important for our angle. It has to be between the two sides. So we have to choose these two. Now, how did I decide what order? Well, we start here at E, and I went toward my angle. So I start here at N and go toward my angle. So that's how you name them. And we can check our congruence statement, E back to L, N back to B. So that's the right order, because it's in the proper order in our congruence statement. All right, let's determine if the triangles are congruent. Would we use side, 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 or side, angle, side, or is there just simply not enough information? Well, let's look at these. I have a side, and another side, and another side. This is looking good so far. And an angle, and an angle. I see two sides and an angle, and the angle is included. So that would be SAS, because we have sides and the included angle. So that one was good. All right, let's look at the next one. What do we have? We have a side and a side and a side and a side. Oh, it's looking good here. And an angle and an angle. I have two sides and an angle. Are these triangles congruent? Well, we don't know. There's not enough information because you have sides, but the angle is not included. We would have needed that angle right there. So these triangles may be congruent, but we certainly cannot prove it at this time. So there's not enough information there. What about C? What are we given? Well, I've got a side and a side, and another side and another side, and a third side and a third side. Yeah, these are easy to see. We have three congruent sides. We have three pairs of corresponding sides that are congruent. So side, side, side postulate. What about this one over here? Well, I see a side and a side, and another side and another side, and a third side and a third side. So we could use SSS postulate. What else do you see? Do you see it here? That should jump out at you and scream at you, vertical angles. So we also have side, angle, side postulate, because we've got the included angle between the purple side and the blue side. It's between the purple and blue side on both of them. So we could use either here. We've got 3 pairs of corresponding sides and a pair of included angles by vertical angles. So again, thank you, geometry, for having multiple options for us. All right, let's just look at this last one here together. Would you use SSS or SAS? Tell me what you think. I see 1, 2, 3 sides. That says SSS to me, but we have an angle. So let's take a look at our angle here. Is our angle in the right spot? No, it is not. What's it between on the first triangle? It's between our blue and green angles here, and it's between green and purple over here. So our angle is not included. We cannot use it this time. So these are very straightforward. Instead of looking for all corresponding sides to be congruent and all corresponding angles to be congruent, we have now said, yes, there is an easier way. If all 3 sides, corresponding sides, are congruent, then your triangle is congruent. That's our SSS postulate. And then we also said, if 2 sides are congruent and the included angle, don't forget the angle has to be included. That's why it's the SAS. The angle, it has to be in between those 2 sides, that those triangles can be congruent. So we now have side, 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 and side, angle, side to make our lives a little easier. Use your define, explore on your proofs, and I am certain that you will do very well on them.